Is line A or B longer? Is the horizontal or vertical line longer? Is the top or bottom line longer? Keep looking. In all of these images, they're actually the same length. You may have seen these before, but you're more susceptible to be tricked by these illusions or not, depending on where you live. Two studies 50 years apart showed that non-Western people were less likely to be tricked by the Mueller-Lyer or parallelogram illusion than Americans or Europeans. And they were more susceptible to the horizontal-vertical illusion. The researchers suggested the physical environment you live in shapes your susceptibility to certain illusions. If you live in an area with a lot of open plains, you're more susceptible to the horizontal-vertical illusion because you're not as familiar with seeing horizontal or vertical objects at different scales. Urban dwellers are moderately susceptible. People who live in restricted environments, like a dense forest, or a big city aren't as easily tricked. There's plenty of straight line things around for us to develop a frame of reference, like tall buildings or trees. It's mind-blowing to think the visual experiences you've had in life affects your perception of objects. Our basic biological process of seeing something, like these lines, is the same, but we've all developed different habits of how we perceive them. And experiments have manipulated the process of how we see objects. In cats wearing an eye patch. In one study, a kitten reared with an eye patch over one eye for 6 months had impaired depth perception. The cat still had two normal eyes, but a greater area of the visual cortex was devoted to analysing information from the unpatched eye rather than the patched eye. Another study went a whisker further. Researchers in the 70s raised two groups of kittens in the dark, and when they were exposed to light, they wore goggles that restricted them to seeing either horizontal or vertical lines. When the goggles were removed, the cats were blind to lines running the other way. The horizontal cats could sit on a chair, but they would bump into the chair's legs. The vertical cats could avoid the chair's legs, but missed when they tried to jump on the chair. The researchers discovered the visual cortex contains certain nerve cells called feature detectors. They respond only when we're shown a line with a certain orientation, like horizontal or vertical. The cat's brains dedicated these nerve cells to one orientation and neglected the other. Just like the influence of where we live, the early visual experiences of the cat shaped how they perceived the physical world.
The researchers actually listened in to individual nerve cells firing in the anesthetized cat as they presented it with different visual images.
When we started working, Torsten and I, in the late 50s, we set up our first experiments, and they didn't go well because at the beginning we couldn't make the cells fire at all. We'd shine lights all over the screen and nothing seemed to work. And rather by accident, one day, we were shining small spots, either white spots or black spots, onto the screen. And we found that the black dot seemed to be working in a way that at first we couldn't understand until we found that it was the process of slipping the piece of glass into the projector, which swept a line, a very faint, precise, narrow line across the retina. And every time we did that, we'd get a response.